Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a circle. Inside this circle we have triangle ABC. We also know that side AB of this triangle ABC equals to 13 units, side BC equals to 14 units in its length, and side AC equals to 15 units. Our mission is to find out the area of this green shape. So we'll start with the first method. I will present to you a new rule and we will implement a new rule in our drawing. The new rule is rule number 4. So in the drawing we have triangle ABC. We know that side AB of this triangle equals to A, side BC equals to B, and side AC equals to C units in its length. In addition, the semi-perimeter of this triangle, that is to say S, the semi-perimeter S equals to the perimeter over 2. That is to say the semi-perimeter S of this triangle ABC equals to A plus B plus C over 2. So the area of this triangle ABC according to the new formula is equal to the square root of S, when S is the semi-perimeter, S times S minus A times S minus B times S minus C. So actually we'll implement the new rule in our drawing. First of all, we define side AC as A, and we know that A equals to 15. We define side AB of this triangle ABC as A, and we know that A equals to 13 units in its length. We define the length of side BC as B, and we know that B equals to 14 units in its length. And finally, we define the length of side AC from this triangle ABC as C, and we know that C equals to 15 units in its length. In the next step, we will calculate the semi-perimeter of this triangle ABC. So first of all, I write it down that A equals to 13, B equals to 14 units, and C equals to 15. So the semi-perimeter of this triangle ABC, according to the new formula, equals to the perimeter, that is A plus B plus C, that is the sum of its side lengths, over 2. So the semi-perimeter of our triangle ABC equals to A, that is 13, plus B, that is 14, plus C, that is 15, over 2. Here 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter S of our triangle ABC equals to 21 units. A equals to 13, B equals to 14, and C equals to 15. And the area of this triangle ABC according to rule number 4 the area of triangle ABC, here the square brackets is the sign for the area. The area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. So the area of our triangle ABC is equals to the square root of S. S is 21 times S minus A. S minus A is 21 minus 13 times S minus B. S minus B is 21 minus 14 times S minus C. S minus C is 21 minus 15. All are under the root. So the area of our triangle ABC equals to the square root of 21 times 21 minus 14 is 8 times 21 minus 14 is 7 times 21 minus 15 is 6. So the area of our triangle ABC equals to the square root of 21. We will substitute 21 by 3 times 7 times 8. We will substitute 8 by 2 times 2 times 2 times 7 times 6. We will substitute 6. We substitute 6 by 3 times 2. In the next step, we will arrange the numbers in a different order inside the root, and finally we will get that the area of our triangle ABC, according to the new rule number 4, is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. Repeat again. If I know that according to rule number 4, the area of triangle ABC equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times 2 times 2. So the square root of 3 times 3 is 3 times the square root of 7 times 7 is 7 times the square root of 2 times 2 is 2, and we have 2 times 2 again, so the square root of 2 times 2 is 2. So the area of triangle ABC in total equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in conclusion, we found out that the area of our triangle ABC, in total it is equals to 84 square units. Okay. From the drawing, it is very clear that the area of the green shape equals to the area of the circle minus the area of triangle ABC. We have already found out that the area of triangle ABC is equals to 84 square units. Now we will find out the area of the circle, and we will subtract the area of the circle minus the area of triangle ABC. This will give us the area of the green shape. So in the next step, I will present to you a new rule that is actually rule number 6, and we will implement rule number 6 in our drawing. According to rule number 6, the radius of a circle that blocks triangle ABC equals to R equals to A times B times C over 4 times the area of triangle ABC. So in the drawing we have a circle. Inside this circle we have triangle ABC. Actually, triangle ABC is blocked by this circle. We also know that the length of side AB is A units, side BC equals to B units in its length, and side AC of this triangle ABC equals to C units in its length. according to our definition, the radius of this circle is r. So according to rule number 6, the radius of this circle r that blocks triangle ABC is equals to a times b times c. That is the multiplication of the side lengths of this triangle ABC by each other over 4 times the area of this triangle ABC that is blocked by this circle. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have this circle that blocks triangle ABC. So according to, we define the radius of this circle as r. Here point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius of the circle that we define as r. So the radius r of this circle that blocks triangle ABC, according to rule number 6, the radius r of this circle that blocks triangle ABC must be equal to a times b times c over 4 times the area of this triangle ABC. R equals to a times b times c over 4 times the area of triangle ABC. This is according to rule number 6. A equals to 13, B equals to 14, and C equals to 15 over 4 times the area of triangle ABC. We have already found out that the area of triangle ABC is equals to 84 square units. So it is 4 times 84 square units. In the next step, we will divide both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1, so we left only with 13 times 15 over 4 times 84. So it is 4 times 84. 84 over 14 is 6. So in total, the denominator we left only with 4 times 6. In the next step, we will divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So in total, in the numerator we left only with 13 times 5 over 4. In the denominator we have 4 times 6 over 3 is 2. So in total, in the denominator we left only with 4 times 2, that is 8. In the numerator we have 13 times 5, that is 65. So actually we found out that the radius of this circle r equals to 65 over 8 units. I write it down. The radius r of this circle that blocks triangle ABC is equal to r equals to 65 over 8 units. Okay. The radius r equals to 65 over 8 units. I repeat again that the area of the green shape equals to the area of the circle minus the area of triangle ABC. So I write it down. The area of the green shape equals to the area of the circle minus the area of triangle ABC. So actually the area of the green shape equals to the area of the circle that is pi r square minus the area of triangle ABC. We have already found out that the area of triangle ABC equals to 84 square units. So the area of the circle is pi r square, but r is 65 over 8, so it is pi times 65 over 8 square. That is the area of the circle minus the area of triangle ABC, that is equals to 84 square units. This expression in total, pi times 65 over 8 square, equals to 207.394 square units minus the area of the triangle ABC, that is 84. So actually 207.394 minus 84, it is equals to 123.394 square units. So actually found out that the area of the green shape in total, it is equals to 123.394 square units. Okay, repeat again. We actually found out that the area of this green shape equals to 123.394 square units. So we finished with the first method. In the next step I will present to you how to find out the area of this green shape according to the second method. In the second method, we'll do a construction. That is to say, from point A, we will go perpendicular on BC. Repeat again. From point A, we will go perpendicular on side BC of the triangle. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. We define the length of side AM as H, and we define the length of side BM as X. What is the length of side MC? What is the length of side MC or CM? CM, it is very easy to see from the drawing that CM equals to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. In the next step, I will copy the right triangle, triangle A and B in a new page, and we will implement on this right triangle, triangle A and B, the Pythagoras theorem. So actually, this is the right triangle, triangle AB that they copied from the original drawing. AM equals to H and BM equals to X according to our definition. Side AB, the hypotenuse AB of this triangle, triangle ABC, it is equals to 13 units according to what is given us in the question. Here by PT is the relation from Pythagoras theorem, so according to the Pythagoras theorem, in this right triangle, triangle A and B, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 squared, that is 169, and it is equals to AM square. AM is 8, therefore AM square is 8 squared, plus BM square. BM is X, therefore BM square is X squared. Here we subtract X squared from this equation, equation number 1, and we get that according to equation number 1, X squared equals to 169 minus X squared. In the next step, I will copy the right triangle, triangle AMC in the new page, and we will implement on this right triangle, triangle AMC the Pythagoras theorem. So this is the right triangle, triangle AMC that I call it from the original drawing. Side AC equals to 15 units according to what is given as the question. We have already found out that side MC equals to 14 minus X and AM equals to H according to our definition. Here by PT is a relation for Pythagoras theorem. So in this right triangle, triangle AMC according to the Pythagoras theorem, this will be equation number 2. AC square equals to AM square plus MC square. AC is 15, therefore AC square is 15 square, that is 225, and it is equals to AM square. AM is 8, therefore AM square is 8 square plus MC square. MC is 14 minus X, therefore MC is 14 minus X square. Here we subtract from this equation, equation number 2, 14 minus X square, and we get that according to equation number 2, X square equals to 225 minus 14 minus X square. This is according to equation number 2. But according to equation number 1, we have already found out that here H square equals to 169 minus X square. So we have two different equations for H square. Therefore, we create equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 equals to 169 minus x squared, and it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So according to equation number 3, we actually found out that (169) minus x squared equals to 225 minus, actually 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So actually found out that according to equation number 3, 169 minus x squared equals to 225. Here we will open the brackets and we get here minus 196 minus x squared, minus and minus is plus, so it is plus 28x. So here we have minus x squared on both sides of the equation, so x squared will get cancelled. So in this side of the equation number 3, after we cancelled minus x squared, we left only with 169 . On the other side of the equation, after we cancelled minus x squared, we have 225 minus 196 is 29 plus 28x. So here we subtract 29 from this equation, equation number 3, and we get that according to equation number 3, 169 minus 29 is 140. That is equals to 28x. Here we divide this equation, equation number 3, by 28, and finally we get that x equals to 140 over 28 is 5. So x equals to 5 units in its length. According to equation number 1, h squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared, but x is 5, therefore x squared is 25. So here it will be minus 25. X squared is minus 25. So h squared equals to 169 minus 25, that is 144. So in conclusion, we found out that according to equation number 1, h squared equals to 144. Here we take a root out of this equation, equation number 1, and finally we get that h equals to the square root of 144, that is 12. Okay, so actually found out that h equals to 12 units in its length, and x equals to 5. Okay, so in the next step, we define the center of this circle as O. We will join points O and A together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as r, therefore OA equals to r. In the next step, we'll extend the radius AO until it touches the circle. And we will define the touching point of the extended radius AO with this circle as point P. We extended the radius AO, that is absolutely a straight line, by straight line. When you extend it a straight line by straight line, the result is a straight line. So AP is a straight line, but AP is a straight line that touches the circle at points A and P. Therefore AP is a chord that passes from point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, chord AP is the diameter of the circle. So I will write it down. AP is the diameter of the circle. We know that the diameter of any circle is twice as long as the radius. The radius is r, therefore the diameter AP must be equal to 2r. Here we know that point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of this circle that is equal to r. From the drawing itself, it is very easy to see that AP, chord AP in total equals to r plus r, that is to r. Okay, so the diameter AP indeed equals to r. In the next step, we will join point C and P together by a straight line. By joining point C and P, we actually created here peripheral angle ACP. This peripheral angle ACP rests on chord AP, that is the diameter of the circle. And we have rule number 7 that says that any chord that rests on the diameter, any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. Repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. Here we have peripheral angle ACB that rests on chord AB, and AB is the diameter of the circle, therefore peripheral angle ACB is equal to 90 degrees. We can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on chord AP, therefore this peripheral angle ACP is equal to 90 degrees, according to rule number 7. In the next step, I will present to you rule number 8 and we'll implement rule number 8 in our drawing. Moving to rule number 8. Peripheral angles that rest on the same chord are equal to each other. In the drawing we have two peripheral angles. This peripheral angle ADB, rests on chord AB. The other peripheral angle ACB, also rests on the same chord AB. So those two peripheral angles that rest, they both rest on the same chord AB, therefore they must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. We can implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle. In our drawing we have peripheral angle ABC. This peripheral angle ABC. This is peripheral angle ABC. that rest on chord AC. Again, peripheral angle ABC rests on chord AC. But we have also another peripheral angle APC. This peripheral angle rests on the same chord called AC. So, in our drawing, we have those two peripheral angles. They both rest on the same chord called AC. Therefore, according to rule number 8, they must be equal to each other. That is to say, if we define peripheral angle ABC as theta, then the other peripheral angle APC must be also equal to theta in its size. Okay. In the next step, we'll focus on the right triangle ABM. On the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the right triangle APC. In the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the right triangle A and B is similar to the right triangle APC. So I write it down. We'll prove that the right triangle A and B is similar to the right triangle APC. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. We can write down that this is angle ABM, and it is equal to this angle. This is actually angle APC. Repeat again. Angle ABM in triangle A and B equals to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, we have those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle A and B, and it is equal to this angle ACM. Repeat again, angle A and B in triangle ABM equals to angle AC. Actually, this is angle ACP. Repeat again, angle A and B in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MAB, triangle ABM, and it is equal to this angle, this is actually angle CAP, in triangle APC, so repeat again, angle MAB in triangle ABM equals to angle CAP in triangle ACP. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in this triangle ABM are correspondingly equal to all the three angles in this triangle APC. Therefore we actually proved that those two right angles are similar to each other according to angle similarity rule. So I'll write it down. Triangle AMB, right triangle AMB is similar, this is the sign of similar, to the right triangle APC according to angle similarity rule. And from the fact that those two right angles are similar to each other, we conclude that the following relationship exists between their sides. We conclude that AB triangle AMB over AP in triangle APC is equal to AM in triangle ABM over AC in triangle APC. Repeat again, we derive that AM over AP equals to AB over AP equals to AM over AC. AB is 13 over AP. AP is the diameter of the circle that is equal to 2R. And it is equal to AM. AM is 12 over AC. AC is 15. In conclusion, found out that 12 over 2R equals to 13 over 2R equals to 12 over 15. Here we'll cross multiply this equation and we get that 13 times 15 equals to 2R times 12. So here we'll divide this equation by 12 and we'll get that 2R equals to 13 times 15 over 12. Here we'll divide this equation by 2 and finally we'll get that the radius of this circle R equals to 13 times 15 over 12 times 2. So we will divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5. So total in the numerator we left only with 13 times 5. In the denominator we have over 12 times 2. So it will be 2 times 12 over 3 is 4. So in total, in the denominator we left only with 2 times 4. 2 times 4 is 8, and 13 times 5 is 65. So we actually found out that the radius of this circle that belongs to triangle ABC equals to R equals to 65 over 8 units. So I write it down. The radius R of this circle is equals to 65 over 8 units. I repeat again that the area of this green shape equals to the area of the circle minus the area of triangle ABC. So I write it down again that the area of the green shape in total, it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is equals to pi r squared minus the area of triangle ABC. What is the area of triangle ABC? From the drawing it is very easy to see that the area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is h over 2. This is the base that is BC times the height to the base times the height to the base that is h over 2. So the area of the triangle is equals to pi r squared, but r is 65 over 8, therefore r squared is 65 over 8 squared. So pi r squared is pi times 65 over 8 squared, that is the area of the circle, minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times h, that is 12, over 2. So actually this expression, in total, pi times 65 over 8 squared, in total it is equals to 207.394 square units, minus the area of triangle ABC. It is, this expression equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC equals to 84 square units, and here we have, in total we get that the area of the green shape is equals to 207.394 minus 84, that's actually 123.394 square units. I repeat again, the area of this green shape according to the second method also is equals to 123.394 square units. So we finished with the second method. In the next step, I'll summarize the lecture. We'll start with the first method. So our mission in this question was to find out the area of this green shape. From the drawing it is very clear that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Okay, in the drawing we have a circle. Inside this circle we have triangle ABC. We know that side AB of this triangle ABC equals to 14 units, side BC equals to 14 units itself, and side AC equals to 15 units. So in order to find out the area of the green shape, I presented to you a new rule and we implemented the new rule in our drawing. The new rule is actually rule number 4. According to rule number 4, here we have triangle ABC that could be any triangle. The length of side AB is A units, side BC equals to B units in its length, and side AC equals to C units in its length. The semi-perimeter of this triangle, triangle ABC, equals to the perimeter over 2. That is to say, it is A plus B plus C over 2. So S, the semi-perimeter S, equals to A plus B plus C over 2. So the area of the triangle ABC that could be any triangle equals to, the square brackets is the sign for the area. The area of triangle ABC that could be any triangle equals to the square root of S. S is the semi-perimeter, that is A plus B plus C over 2. Times S minus A times S minus B times S minus C. So if we implemented the new rule in our drawing in order to find out the area of our triangle, triangle ABC. But first of all, we defined side AB is A, and we know that A equals to 13 units. We define side BC of the triangle ABC is B, and B equals to 14. We define the area for side AC is C, and C equals to 15. Repeat again. According to our definition, A equals to 13, B equals to 14, and C equals to 15. We found out the semi-perimeter of our triangle, triangle ABC. The semi-perimeter of triangle ABC equals to A plus B plus C over 2. That is the perimeter over 2. A is 13, B is 14, and C is 15 over 2. 13 plus 15 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So if we only found out that the semi-perimeter of this triangle ABC equals to 21 units. S equals to 21. And again, A equals to 13, B equals to 14, and C equals to 15 according to our definition. So the area of triangle ABC according to rule number 4 equals to the square root of S times S minus A times S minus B times S minus C. So the area of triangle ABC equals to the square root of S. S is 21, S minus A is 21 minus 13, S minus B is 21 minus 14, and S minus C is 21 minus 15. So the area of triangle ABC equals to the square root of 21 times 21 minus 14 is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. Then we substitute 21 by 3 times 7. We substitute 8 by 2 times 2 times 2. We have here also 7. And we substitute 6 by 3 times 2. In conclusion, we found out that the area of triangle ABC equals to the square root of 3 times 7 times 2 times 2 times 2 times 7 times 3 times 2. Then we change the orders of the numbers inside the root. And found out that the area of our triangle ABC according to the new rule number 4 is equals to the square root of 3 times 3 times 7 times 7 times 2 times 2 times 2 times 2. The square root of 3 times 3 is 3, the square root of 7 times 7 is 7, the square root of 2 times 2 is 2, and we have again the square root of 2 times 2 is 2. So the area of triangle ABC in total equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. In conclusion, we found out that the area of our triangle, this triangle ABC, equals to 84 square units. Then I presented to you rule number 6, and we implemented rule number 6 in our drawing. According to rule number 6, in the drawing we have a circle that blocks this triangle ABC. According to our definition, the radius of this circle is R, and so this circle blocks this triangle ABC. The length of side AB of this triangle ABC equals to A units, side BC equals to B unit in its length and side AC equals to C units in its length. So according to this rule number 6, the radius of this circle R that blocks triangle ABC equals to A times B times C, that is the multiplication of the sides and lengths of the triangle by each other, over 4 times the area of this triangle, triangle ABC. We can implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks triangle ABC. We define the radius of this circle R as R. So according to rule number 6, the radius R of this circle that blocks triangle ABC will be equal to A times B times C over 4 times the area of triangle ABC. And we already found out that the area of triangle ABC that is blocked by the circle is equal to 84 square units. So R equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC, that is 84. Then we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14, 14 over 14 is 1, so we left only with 13 times 15. In the denominator we have 4 times 84. So it is 4 times 84 over 14 is 6. So in total, in the denominator we left only with 4 times 6. Then we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So it will be 13 times 15 over 3, that is 5. So in total in the numerator we left only with 13 times 5 over 4 times 6. In the denominator we have 4 times 6. So it will be 4 times 6 over 3 is 2. So in total in the denominator we left only with 4 times 2, that is 8. And 13 times 5 is 65. So actually we found out in conclusion that the radius of this circle that blocks triangle ABC, the radius R equals to 65 over 8 units. What is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the circle minus the area of this triangle, triangle ABC. I repeat again, the area of the green shape is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared. And we have already found out that the area of triangle ABC is equal to 84 square units. So the area of the green shape in total equals to pi r squared minus 84 square units. The area of the circle is pi r squared, but r equals to 65, therefore r squared is 65 over 8 squared. So in total pi r squared equals to pi times 65 over 8 squared minus the area of triangle ABC, that is 84 8 squared. This expression in total equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. 207.394 minus 84 equals to 123.394 square units. So in conclusion, found out that the area of this green shape, according to the first method, is equals to 123.394 square units. So we finished with the first method. In the next step I presented to you how to find out the area of this green shape according to the second method. In the second method, we did a construction, that is to say from point A we draw perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as M. Then we define side AM as H and we define side BM as X. What is the length of side CM? From the drawing it is very easy to see that CM equals to CB minus MB. That is to say CM equals to CB, that is 14, minus MB, that is X. So in total CM equals to 14 minus X. Then I copied the right triangle, triangle A and B, the new page, and we implemented on this right triangle A and B the Pythagoras theorem. This is the right triangle, triangle A and B that I copied from the original drawing. By PT is the version for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle, triangle A and B, AB square equals to AM square plus BM square. AB is 13, therefore AB square is 13 squared, that is 169, and is equals to AM square. AM is x, therefore AM square is x square plus BM square. BM is x, therefore BM square is x square. So, according to equation number 1, we found out that 169 equals to x square plus x square. Here we subtracted x square from this equation, equation number 1, and finally found out that according to equation number 1, x square equals to 169 minus x square. Then I copied the right triangle, triangle AMC here in the new page, and we implemented the Pythagoras theorem on this right triangle, triangle AMC. This is the right triangle, triangle AMC that I copied from the original drawing. AC equals to 15 units according to what is given as the question. We have already found out that CM equals to 14 minus x and AM equals to 8 according to our definition. So in this right triangle, triangle AMC, according to the Pythagoras theorem, AC square equals to AM square plus MC square. So AC is 15, therefore AC square is 15 squared, that is 225, and it is equal to AM square. AM is x, therefore AM square is x square plus MC square. MC is 14 minus x, therefore MC square is 14 minus x square. Here we subtracted 14 minus x square from this equation, equation number 2, and finally found out that according to equation number 2, x square equals to 225 minus 14 minus x square. Well, according to equation number 1, we have already found out that x square equals to 169 minus x square. So we have two different equations for x square. Therefore, we created equation number 3 that states that x square according to equation number 1 must be equal to x square according to equation number 2. X square according to equation number 1 equals to 169 minus x square. And it must be equal to x square according to equation number 2. X square according to equation number 2 equals to 225 minus 14 minus x square. So according to equation number 3, we have found out that 169 minus x square equals to 225 minus 14 minus x square equals to 14 squared, that is 196, plus x square minus 2 times 14x, that is minus 28x. So according to equation number 3, we actually found out that 169 minus x square equals to 225. We open the brackets here. After we open the brackets here, we will get minus 196 minus x square, minus is plus, so it is plus 28x. So here we have minus x square on both sides of the equation, so minus x square will get cancelled. So in this side of the equation, after we cancelled minus x square, we left only 169. On the other side of the equation, we have 225 minus 196, that is 29, plus 28x. So conclusion, according to equation number 3, we found out that 169 equals to 29 plus 28x. Here we subtracted 29 from this equation, equation number 3, and we found out that according to this equation, equation number 3, 169 minus 29 is 140, so 140 equals to 28x. Here we divided this equation, equation number 3, by 28, and finally we found out that x equals to 140 over 28, that is 5. So x equals to 5. According to equation number 1, x square equals to 169 minus x square. So x square equals to 169 minus x square. X is 5, therefore x square is 5 squared, that is 25. So x square, according to equation number 1, x square equals to 169 minus 25. 169 minus 25 is 144. So in conclusion, found out that according to equation number 1, h squared equals to 144. We took out all of this equation and finally found out that h is equals to the square root of 144, that is 12. So you can write down here that h equals to 12 and x equals to 5. Then we define the center of this circle is O. We join points A and O together by a straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R. Then we extended the radius AO by a straight line until it touches the circle. We define the touching point of the extended radius AO with this circle as P. When we extend a straight line by a straight line, the result is a straight line. So the result AP is also a straight line. AP is a straight line that touches the circle points A and P. Therefore, AP is a chord that passes from point O, that is the center of the circle. And we know that any chord that passes from the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. The radius is R, therefore the diameter AP must be equal to 2R. Here point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius of this circle that is equal to R. So you can see it from the domain that AP in total equals to R plus R, that is to R. Indeed, AP is the diameter of the circle. Then we join points C and P together by a straight line. By joining points P and C, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it must be equal to 90 degrees. This is peripheral angle ACB that rests on AB. AB is the diameter of the circle. Therefore, peripheral angle ACB is equal to 90 degrees. We can implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. Therefore, this peripheral angle ACP must be equal to 90 degrees according to rule number 7. Then I presented to you rule number 8 and we implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. We have here two peripheral angles. This is peripheral angle ADB that rests on chord AB. The other peripheral angle ACB rests also on the same chord called AB. So those two peripheral angles, they are both rest on the same chord called AB. Therefore, according to this rule, rule number 8, they must be equal to each other. So if this peripheral angle ADB is equal to theta, then the other peripheral angle ACB that rests on the same chord must be also equal to theta. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle ABC. This is peripheral angle ABC that rests on chord AC. But we have another peripheral angle APC that rests on the same chord called AC. So those two peripheral angles, they rest both on the same chord called AC. Therefore, they must be equal to each other. So if we define the size of this peripheral angle ABC as theta, then the other peripheral angle APC that rests on the same chord called AC must be also equal to theta, according to rule number 8. Then we focus on the right triangle, triangle ABM. In the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle, triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the right triangle, triangle ABM is similar to the right triangle, triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So I actually proved that all the three angles in the right triangle ABM are correspondingly equal to all the three angles in the right triangle, triangle APC. Therefore, we proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that here AB in triangle AMB, side AB in triangle AMB, over side AP in triangle APC is equals to side AM in triangle ABM over AC in triangle APC. I repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle that is 2R, AM is 12, and AC is 15. Here we cross multiply this equation, and we found out that 13 times 15 equals to 2R times 12. Here we divided this equation by 12 and found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2 and found out finally that the radius of this circle that blocks triangle ABC, the radius R equals to 13 times 15 over 12 times 2. We divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it is 13 times 15 over 3 is 5. So in total, in the numerator we left only with 15 times 5 over 12 times 2. In the denominator we have 2 times 12. So 2 times 12 over 3 is 4. So in total, in the denominator we left only with 2 times 4, that is 8, and 13 times 5 is 65. So in total we found out that the radius R of this circle is equals to 65 over 8 units. So I repeat again, the radius R of the circle equals to 65 over 8 units. What is the area of the green shape? From the drawing it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. I repeat again, the area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r square minus the area of triangle ABC. What is the area of triangle ABC? It is very easy to see from the drawing that the area of triangle ABC equals to the base of the triangle that is BC times the height of the base that is h over 2. Repeat again, the area of triangle ABC equals to the base that is BC times the height of the base that is h over 2. So the area of the circle is pi r square, but r is 65 over 8, so r square is 65 over 8 square, so in total pi r square equals to pi times 65 over 8 square, minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times h, that is 12 over 2. This expression in total equals to 207.394 square units, and this expression equals to 14 over 2 is 7, and 7 times 12 is 84. So in total the area of triangle ABC equals to 84 square units. 207.394 minus 84 equals to 123.394 square units. So we actually found out in conclusion that the area of this green shape in both methods, it is equals to 123.394 square units. Okay, thank you very much.